Okay, now with the solutions to question 7. First one, we are to show that the value of k equals to 2. We notice that ABC is an isosceles triangle. So therefore, if being isosceles, the length of AB should be equal to the length of BC. Simple application of distance formula will allow us to find the value of k. So I will show you the solution there. For distance formula, okay, we apply the distance formula there. We square both sides of the equation to remove the square root sign. Expanding, we collect all our terms on the left hand side, we factorize and we solve to get k equals to 4 and k is equals to 2. Notice that we reject k equals to 4. Why? If you notice here, k, the y value of b is 3, y value of k is either 2 or 4. But notice that c very obviously lies below b. So therefore the value of k must be 2 and the value of 4 must be rejected. Now 7 part 2 is for us to find the equation of the perpendicular bisector of the line AC. Okay, so there we have AC. First thing first is we can find the midpoint of AC which the perpendicular bisector will pass through. Some of you are quite intelligent. You actually know that since it's an isosceles triangle, if we have the perpendicular bisector of AC, the base of triangle, okay, it will actually pass through point B as well. So both ways will work as well. I will show you my method. Okay, first I found the midpoint of AC, and we found the midpoint is 4.5, 1.5. This simple application of the formula. Gradient of AC, y2 minus y1, x2 minus x1 gives you 1/3. The gradient of the perpendicular bisector, m1 times m2 is -1. So we know that the gradient of the bisector is -3. We put it into the equation. There are two ways to do this. One is we say y equals to -3x plus c, gradient is -3. We substitute a point. In this case, we use 4.5, 1.5, which is the midpoint of AC. Some of you, as I said, actually know that the perpendicular bisector will actually pass through the vertex B, okay, the point B, because it's an isosceles triangle. So if you substituted 4, 3 over here, you have worked out as well. You have found that the value of C, okay, is 15. This C, of course, we know it is the y-intercept of the line. Okay, so now we know that the perpendicular bisector, the equation now is y equals to -3x plus 15. Part 3 actually asks us to find that the line, okay, the bisector meets the x-axis at D. Along the x-axis, we know that the y value is 0. Simply, we let y equals to 0. Okay, we find that x equals to 5. But x equals to 5, okay, do not forget that the coordinates of the point is 5, 0. Finally, we find the area of ABCD. Okay, we use the shoelace method. One common error that many of you did not do was that you wrote 50624331. You forgot to repeat the 50 again. Okay, remember if 4 points, you actually have to have 5 pairs over here. Simple application of shoelace method: 5 times 2, 6 times 3, 4 times 1, 3 times 0. You get this. The other way, 6 times 0, 4 times 2 is 8, 3 times 3 is 9, 5 times 1 is 5. Then you just plug everything to the calculator. You notice that the area of ABCD is 5 units square. And I made a slight error there. This is part 4, and you are done for question 7.